Hello everyone, a very warm good morning, good evening, you all guys. How are you all? I hope you are doing great and taking a very good care of yourself and your family. To most welcome to our YouTube channel Uday Kumar 2M guys. In this session, guys, I'm going to solve all VBI questions related to number systems, guys. So now let's begin. Have a look, guys. Express 0.3 over bar in the form of PYQ where P and Q are integers and Q is not equal to 0. Okay? So now let's begin. Have a look, guys. Solution of these questions. Let x is equal to 0.3 3 over bar. Okay? Repeating blocks. Then we can write x is equal to 0.333. Repeat this 3 times or 4 times as you want. Okay? And let equation first. Now you can see here, since the repeating blocks has only one digit 3, so we multiply both sides of equation first by 10 and we get, since the repeating blocks has only one digit 3, so we multiply equation first, we multiply both sides equation first by 10 and we get, after multiplying both sides of equation first we get 10x is equal to 3.333. Okay, let this expression as equation second. Now subtracting equation first from equation second we get, subtracting equation first from equation second. Okay, we get equation second 10x is equal to 3.333 and equation first x is equal to 0.333. Here in left hand side 9x is equal to, in right hand side 3. Okay, 0.000 imply that x is equal to 3 upon 9. Hence x is equal to 1 upon 3. Now we can write thus 0.3 over bar 3 over bar is equal to 1 upon 3. This is the required answer in the form of PYQ. Now let's go ahead to the next questions. But first of all, we have to wipe the board. Okay? So now let's go ahead. Let me wipe the board first. Have a look, guys. Next questions. Express 1.4 over bar. You can say repeating blocks as fraction in simplest form. Have a look, guys. Solution of these questions. We have to express these decimal numbers as fraction in simplest form. So let x is equal to 1.4 over bar. Then this can be written as x is equal to 1.444. Let this expression as equation first. Now we can see here, since repeating blocks has only one digit 4, so we multiply both sides of equation first by 10 and we get, since the repeating block has only one digit 4, so we multiply both sides of equation first by 10 and we get after multiplying both sides of equation first by 10, we get 10x is equal to 14.444. Let this expression as equation second. Is it clear? Now subtracting equation first from equation second, we get, now subtracting equation first from equation second, we get, after subtracting equation first from equation second, we get 9x is equal to 13. Am I right? Imply that x is equal to 13 upon 9. So we have to express 13 upon 9 in its simplest form. You can say as a mixed fraction. So we can write hence x is equal to 1 whole 4 upon 9. Hence, 1.4 over bar is equal to 1 whole 4 upon 9. This is the required answer. Now let's go ahead to the next questions. Okay? 0.999 dot dot as fraction in simplest form. Similarly, let x is equal to sorry yaar, let me dry the board first. Dry up the board first, okay? Let x is equal to 0.9999 as equation first, okay? Since the repeating blocks has only one digit 9, so we multiply both sides of equation first by 10 and we get 10x is equal to 9.9999 as equation second. Now subtracting equation first from equation second to get, and we get 9x is equal to 9. Okay? Imply that x is equal to 9 upon 9. Hence x is equal to 1. Hence 0.9999 is equal to 1. This is the required answer. Now let's go ahead to the next question. express each of the following decimals in the form of P by Q, where P and Q are integers and Q is not equal to 0. First, 0.57 over bar. Second, 0.2 over bar. Third, 0.001 over bar. Fourth, 2.4178 over bar 178. Okay. Next, 0.53 over bar. Have a look, guys. Solution of question of first. Let x is equal to 0.57 over bar. Then x is equal to 0.5757 as equation first. The repeating blocks has only two digits 5 and 7. So we multiply both sides of equation first by 100 and we get 100x is equal to 57.5757 as an equation second. Okay. Subtracting now, subtracting equation first from equation second and we get 99x is equal to 57. Okay. Imply that x is equal to 57 upon 99. Thus, we can write 0.57 over bar 57 is equal to 57 upon 99. This is the required answer. Okay. You can also write this as after cancelling this by 19 sorry 3 we get 19 upon 33. Dividing numerator and denominator by 3 we get 19 upon 33. Okay. Now let's go ahead to the next questions. Question number second. Have a look, guys. Solution of question number second. Let x is equal to 0.2 over bar. Then we can write x is equal to 0.222. Let this expression as an equation first. Here we can see the repeating blocks has only one digit 2. So we multiply both sides of equation first by 10 and we get 10x is equal to 2.222. Let this expression as an equation second. Now subtracting equation first from equation second and we get 9x is equal to 2, imply that x is equal to 2 upon 9. Hence, we can write this as 0.2 over bar is equal to 2 upon 9. This is the required answer. Now let's go ahead to the next questions. But first of all, we have to wipe the board. So let me wipe the board. Okay. Let me wipe the board first. Have a look, guys. Solution of next questions. Question number 3. Let x is equal to 0.001 over bar. Then we can write this as x is equal to 0.001001. Let this expression as an equation first. Okay. Now we can see here the repeating blocks has only 3 digits 001. So we multiply both sides of equation first by 1000 and we get, after multiplying equation first by 1000, we get 1000x is equal to 1.001. Let this expression as an equation second. Now subtracting equation first from equation second we get, now subtracting equation first from equation second we get 999x is equal to 1, imply that x is equal to 1 upon 999. Hence 0.001 over bar is equal to 1 upon 999. This is the required answer. Okay. This is the required answer. Now let's go ahead to the next questions. Question number 4. Question number 4. Let x is equal to 2.4178 over by 178. Then we can write this as x is equal to 2.4178178 as an equation first. Okay. Now we can see clearly here the repeating blocks has 3 digits 178. So we multiply both sides of equation first by 1000 and we get 1000x is equal to 2417.8178. Let this expression as an equation second. Now subtracting equation first from equation second and we get 999x is equal to 'let me subtract this. We take 4 digit after decimal point, okay, in both equation, because then it will be easy to solve these equations. Okay, so let me subtract first. Here we can see 4 digit and here we can see 4 digit after decimal point. So 8 minus 8 0, 7 minus 7 0, 1 minus 1 0, and 8 minus 4 4. Now insert point. 7 minus 2 5, and remaining digit as it is 1 4 2. So now we can erase this 0 after decimal point because it doesn't mean something. So let me erase this digit, okay, because it will be easy to solve these equations. So now we can write x is equal to 2415.4 upon 999. Now to remove this point, we insert 10 in denominator and we can write x is equal to 24154 upon 999. Okay, you can cancel this by 2. Okay, 54978. After cancelling numerator and denominator by 2, we get 12077 upon 4 9 9 Okay. Hence, or thus, or therefore, we can write 2.4178 over bar 178 is equal to 12077 upon 4995. This will be a required answer. Okay. Now let's go ahead to the next questions. But we have to wipe the board first. Okay. So let me wipe the board. Now have a look, guys. Next questions. Question number 5. Let x is equal to 0.53 over by bar 53. Okay. And then we can write x equal to 0.5353 and let this expression as an equation first. Now we can see here clearly the repeating digit has only two digits, 5 and 3. So we multiply both sides of the equation first by 100 and we get 100x is equal to 53.5353. Let this expression as an equation second. Now subtracting equation first from equation second, we get 99x is equal to 53. Imply that x is equal to 53 upon 99. Hence, we can write 0.53 over bar is equal to 53 upon 99. This will be the required answer. Okay, it will be the required answer. Now let's go ahead to the next questions. Question number 6. 2.93 over by 93. Let x is equal to 2.9393 as an equation first. We can see here the repeating blocks has only two digits, 9 and 3. So we multiply both sides of equation first by 100 and we get 100x is equal to 293.93. Let this expression as an equation second. Now subtracting equation first from equation second and we get 99x is equal to 291. Imply that x is equal to 291 upon 99. Okay. Am I right? Okay. Now let's go ahead. Here we can see both numerator and denominator. By after dividing numerator and denominator by 3, we get 97 upon 33. Hence 2.93 over bar 93 is equal to 97 upon 33. This will be the required answer. Avdesh Kumar ji, hello. Hey Avdesh, is everything fine? I hope you are doing great and taking a very good care of yourself and your family too. Now let's go ahead to the next question. But first of all, we have to wipe the board. Okay, so let me wipe the board. Have a look, guys. Next questions. Question number 7. 18.84 over bar 84. Let x is equal to 18.84 as an equation first. Here we can see the repeating digits has only two digits, 8 and 4. So we multiply both sides of equation first by 100 and we get 100x is equal to 1884.8484. Let this expression as an equation second. Now subtracting equation first from equation second, we get subtracting equation first from equation second, and we get 99x is equal to 1866. Okay, imply that x is equal to 1866 upon 99. You can write this as am I right? Let me check it first. Okay, Yes, this now you can write 18.84 over bar 84 is equal to 622 upon 3 3. Let me check it once again. Okay, if you find any error, so let me check it once again. This is the required answer. Now let's go ahead to the next questions. Welcome to our live session. Welcome you all, guys. I welcome you all to our live session, guys. In this session, I'm going to solve all important questions related to number system. Okay. Have a look, guys. Next questions. 0.235 over bar. Let 0 x is equal to 0.235 over bar, then we can write this expression as x is equal to 0.235. Let this expression as an equation first. Here we can see the repeating digits has only 3 digits, 2, 3, 5. So we multiply both sides of equation first by 1000 and we get, after multiplying 1000 on both sides of the equation first, we get 1000 x is equal to 235.235. Let this expression as an equation second. Now subtracting equation first from equation second, and we get 999x is equal to 235. Imply that x is equal to 235 upon triple nine. Okay. Hence 0.235 over bar is equal to 235 upon triple nine. It will be a required answer. Now let's go ahead to the next questions. 0.0032 over bar 32. Let x is equal to 0.003232. Let this expression as an equation first. Here x is equal to 0.0032 over bar 32. Then x is equal to 0.003232. Let this expression as an equation first. We can see here the repeating digits has only two digits, 3 and 2. So we multiply both sides of equation first by 100 and we get 100x is equal to 0.3232. Let this expression as an equation second. Now subtracting equation first from equation second, and we get 99x is equal to 0.32. Hence, imply that x is equal to 0.32 upon 99. You can write this as 32 upon 9900. After cancelling this by 4, you can get x is equal to 8 upon 4 to the 8, 4 4 the 16, 4 7 the 28, 4 5 the 20. Hence 0.0032 over bar 32 is equal to 8 by 2475. This is the required answer. Now let's go ahead. Pawan S. Hi. I hope you are pretty good and taking a very good care of yourself. Most welcome to our live stream. Now let's go ahead. Have a look, guys. Solution of these problems. Equation first. 3 under root 5 by 2 under root 5 is equal to 3 under root 5 into 2 under root 5 is equal to 3 to the 6 into under root 5, 3 into 2 into under root 5 into under root 5 is equal to 3 to the 6 into under root 5 into 5. Now we can write 6 into 5 is equal to 30. This is the required answer. Now let's go ahead to the next questions. 6 under root 15 by 4 under root 3 is equal to 6 into 4 into under root 15 into under root 3. Now you can write 24 into under root 15 into 3 is equal to 24 into under root. You can write 15 as 3 fives are 15. Okay, so now you can write 24 into, here you can see 3 makes pair, so we can write 3 and a rest part under root 5. So it will be 72 under root 5. This will be the, sorry, this will be the required answer. Now let's go ahead to the next questions. Question number third. 2 under root 6 by 3 under root 3 is equal to, you can write whole part into whole part, 2 into 3 and into under root 6 into under root 3. 3 to the 6 into under root 6 into 3, 6 into under root. You can write 6 as 2 into 3. Okay, here 3 makes pair, so we can take out from root and you can write 6 into 3 and rest part 2 does not make pair, so it will be under root 2. Okay, so you can write 18 under root 2. Now let's go ahead to the next questions. Question number 4. 5 under root 11 by 3 under root 11 is equal to 5 into 3 into under root 11 into under root 11. Now we can write 15 into 11. So 5, 6, 1. Okay. This will be the right answer. Now let's go ahead to the next question. Question number 5. 15 under root 15 by 3 under root 5 is equal to 15 into 3 into under root 15 into under root 5 is equal to 45 into under root 15 into 5 is equal to 45 into under root 3 into 5 into 5. So we can write, after taking a square root of this number, you can write here. You can see 5 makes pair, so it can be taken out a single 5, and it doesn't make pair, so it will be under root. Okay, so you can write 5 5 are 25 to carry over 4 5 are 20 to 22 225 under root 3. Okay, hence 5 under root 11 into 3 under root 11 is equal to 225 under root 3. This will be the required answer. This will be the required answer. Now let's go ahead to the next questions. So first of all, let me wipe the board. Now we have to add this and this. So we can write 3 under root 2 plus 7 under root 3 plus under root 2 minus 5 under root 3 is equal to, now like terms add with like terms. Okay, so now let's go ahead. Now we can write 3 under root 2 plus under root 2 plus 7 under root 3 plus minus 5 under root 3. Now you consider 1 here. Okay, 3 1 4 root 2 common in both terms, so we can write as a common root as a multiple root 2 plus. Now 7 minus 5 is equal to 2 and root 3 as a multiple as a common. So you can see here 2 is present in both terms, so you can write 2 as a common and you can write 2 on the root 2 plus root 3. This will be the required answer. Okay. Now let's go ahead. For today, guys, it is enough. If you find this video informative, interesting, useful, then like, comment, share, and don't forget to subscribe to our channel. Take care. Bye bye. See you soon in next live stream, guys. If you find this video informative, useful, then like, comment, share, and don't forget to subscribe to our channel. Take care. Have a nice day. And have a nice night. Suraj. Oh, Suraj, bro. Most welcome to our live stream. Most welcome. Sir, live is in. Uh, okay. I'm going to disconnect this live stream because I need to go offline. That's why. Uh, if if you are free, then I'll take this live stream uh, as continuous. Okay. So for today, it is enough. Okay. See you soon in next live stream, guys. Okay. Bye bye. Have a great night. Have a sweet dream. See you soon in next live stream. Please share this video among your family and friends as much as you can, guys. I think we need to continue. Good night. Good night.